That's 50 hertz because that's the frequency of the power that we get. But can we use that? Do we use that here at all? No, because we want to look at motion, so we have to convert that into a time. So when we always, your first step is to go and get the period. The period is always the time taken from the one dot to the next dot. So from there to there, that's the period. And from there to there, that's the period. And from there to there, that's the period. Those times are constant. So what is this object doing? Oh, first we need to decide which way it's moving. So you will have an arrow. So let's say this is moving to the right. So now the gaps are getting smaller. If the gaps are getting smaller, what's happening to this car? It's slowing down. If the gaps are getting bigger, so you're almost going opposite to your arrow because this dot was made first. So think about it being pulled this way. So this is the arrow points that way, this is dot 1, dot 2, dot 3, dot 4, dot 5, dot 6, dot 7. Happy with that? Okay, so look at your arrow. This is my direction of my ticker timer. Okay, so you're going to get the period. Period is the equation. Period is equal to 1 over frequency. So for this one, it's going to be 1 over 50, and that's going to be 0,02 seconds. Now look out. For the interval, they might just give you that as your interval there. So if this is one of our intervals, there from the first dot to the second dot, they could say, okay, I'm going to give, let me use a prop arrow. They might give you this distance here. And then they might not give you these because these are small. They might say, okay, I'm going to give you this distance here. Okay. They might not give you the big one here. We don't like testing the same skill twice. So often we give you the velocity in one and we ask you for the other one. But they could ask you for the velocity for both. So for our example, let's just do both. So let's say, remember also, it's on pieces of paper. So it's never going to be meters. It's going to be centimeters or millimeters. So your first job is to convert because it's a mark in the bag. So let's say we told you that this is 150 millimeters. And we tell you that this is, compared to that, I would say probably 12 millimeters. So that's the distances we give you. Okay. Now let's say this is interval A. Be weird. Let's just say A, B, and this is interval C, D. You can label it. If they don't label it, please label it on your diagram. Okay, but we normally label it because it makes our marking easier. All right, so now, typical ticker timer question. You're going to get asked for one velocity. You're going to get asked for the period. Then you're going to get asked for one velocity. You're going to be asked for another velocity or given another velocity. And then you're going to be asked for the acceleration. So you will see the recipe. It goes like that always. So if we want to work out the velocity for that first interval. Sorry, I'm just moving my arrow to the top. So if we want to work out the velocity here, what's my equation that I'm going to use? Or speed?
Distance of the sun.
Please write the equation, because remember it's worth a mark 90% of the time. The only time you don't get a mark for it is if you're using it in the same question now again.
I can say changing X or changing Z.
So for this one, am I going to use 150 millimeters? What am I going to use? 0,15. You divide by 1,000, or you can just say times 10 to the minus 3. Remember your conversions. 10, so but 0,15 is absolutely fine. And now what is my time here? How many intervals do I have there? Only one. So it's only going to be 0,02
Wait, I'm so like it's seconds, then what? You can do it with this.
meters per second. So this is meters and this is seconds. So that my answer can be in meters per second. Say again.
7.5.
Thank you. 7,5 meters per second. And I ask for speed so you don't have to worry about a direction. Otherwise, it would just be to the right. Now for this one. If I go and get the, so this is my VI. Label it as VI. This is going to be my VF. Again, it's going to be delta X over delta T. I'm just going to go a little bit faster again. So that's going to be 0,012. You all happy with how I get that? Over. Now, how many time intervals are there? There are 2 time intervals. So now you're going to say 2 times 0,02. Is that answering your problem? Again, but this is not where people lose marks. I'm going to get to the more important one now. Again, you just do that on your calculator. And what do you get, Anisha? See?
0.3 meters per second.
0,333.
No, just 0.3 meters.
0,3 on the dot. Meters per second. Write your unit. Every time you leave out a unit, you lose a mark. It's not one of those things we carry over. If you leave a unit, it's a mark gone. Now the next question. 99% of the time will ask you for, what did I say? Acceleration. Now please, what is important is that you remember, when does it reach this velocity of 7,5? Does it reach it in the beginning? Remember, it's slowing down. So is that 7,5 and is that also 7,5? No, in the middle of the time interval. So it reaches that VI in the middle of that time interval. When does it reach the 0,3?
The second part.
In the middle of this time interval. So that is there at that dot there. Does that make sense? So now when I get my acceleration, it's how much faster is it going from that point to that point, because that's my VF and my VI. So now when you write your acceleration, you're going to say acceleration is equal to VF minus VI over delta T. You happy with the equation? VF is 0,3 minus VI, which is 7,5, over. Now this is where people lose marks. Because now I need to decide how many times 0,02 do I need. So you start there, the middle of my first interval, and you count to the middle of your last interval. So let's see. There's 1, 2, 3, 4 and a half. So this is going to be 4,5 times 0,02. Is that the full answer? The whole acceleration?
No.
Oh, just this one. Okay, so you can write an intermediate answer. Remember, the steps in science don't give you marks. We just want this answer now. You can do it all on your calculator in one step and give me the answer.
Negative 80.
Negative
80.
80.
Yeah.
Yo, it's a hectic slowdown, yeah. But it's okay, we just made up the values. So minus 80, what is the unit for acceleration? Meters per second squared. Can I leave my answer like this? No. Acceleration is a vector, so you're going to say, therefore, acceleration is equal to 80 meters per second squared. And we know that was our original direction. That was to the right. So what is this going to be? To the left.